Okay everyone, this is part 2 of my video on the photoelectric effect. If you missed part 1, then go back to the main channel page and have a look. In part 1, we talked about what the photoelectric effect was, some experiments and what they observed, how waves couldn't explain this issue, and then how Einstein came along with this photon solution. And the photon solution was saying that one electron absorbs one photon, and if that photon has this minimum amount of energy, the work function amount of energy, which we gave the symbol theta to, the electron would be able to leave the atom. And if it didn't have the work function of energy, then nothing would happen, which is why UV light, which is higher energy, would release electrons, but visible light would never release electrons. And we came up with a symbol for the threshold frequency. So Einstein extended this further, and he came up with a very important equation, his photoelectric equation, which was to say that HF, the energy of the photon coming in, equals theta, the work function, plus the maximum kinetic energy. And we're going to talk about what each of these means. HF is the energy of the inbound photon. And you have to think, theta is the work function in EV, and that's defined up here. And then this Ke max is the maximum kinetic energy of the released photoelectron. So to put it back into our analogy with the golf ball, HF is my energy of the inbound photon. That's like my input energy. That's the amount of energy that I hit the ball with. So, and theta, the work function, is the amount of energy that I need to get the ball all the way up to the top of the hill. So if my HF is less than theta, that ball will roll up the hill but then come back down. So if I'm looking from the top of the hill, I'm never going to see the ball, no matter what. If my eye's here and looking this way, I will never see that ball. So if HF is less than theta, nothing happens. If HF is more than theta, the ball's reached the top of the hill. But if HF is more than theta, where does our leftover energy go? Because we know energy is conserved. Well, it goes into the kinetic energy of the released photoelectron. I think the harder you hit that ball, when it does get to the top of the slope, the quicker it will be going along or even up into the air potentially. So if HF is much greater than theta, then you get a much greater kinetic energy. And that's why they've observed that the kinetic energy for the UV light was higher than where if violet light had released it. So the higher the energy of the photon, the more kinetic energy, because there's more energy above the work function. We also have this idea about intensity. And we noticed that increasing intensity didn't increase the Ke of electrons in these experiments. So let's talk about it. Why does increasing intensity not increase the amount of photoelectrons below the work function? Well, that's because no photons have enough energy to release photoelectrons. And because of this 1-to-1 ratio, which is our key idea, 1 photon to 1 photoelectron. And I'll bubble that. So it doesn't matter how many I chuck at it below the work function, because none of them in this 1-to-1 ratio are ever going to have enough energy. So I can keep throwing photons at my metal, but it's never going to release electron. Above the work function it is, and so each photon does have enough energy to release an electron. So what we say here above the work function is that the number of released photoelectrons is directly proportional to the intensity of the EM wave, of the EM light. Because let's think about it, the higher the intensity, the more photons I'm throwing at my metal, so the more electrons are going to be released. Now, in terms of the maximum Ke, well, we found in the experiment that this was not related to the intensity. And that's again due to the 1-to-1 ratio. Because each photon is only interacting with one electron. And so my maximum Ke is purely decided by the energy of the photon, which is from Einstein's photoelectric equation. So this is a summary of the photoelectric effect. I know it's a lot of content there. If you have any questions, please feel free to put them in the chat or the comments below. But yeah, I think that pretty much summarizes it. So thank you very much for watching.